Hey everyone, Miss Waz here. So this lesson is going to focus on simplifying radicals, but we're going to look at radicals that are not perfect squares. So I'm going to go through the basic steps, give you some examples, and then give you some strategies that will help you simplify the radicals.
So I want us to become a little familiar with some terminology around a radical. So this whole thing is called a radical, and this black part would be the radical symbol. And then we have two pieces that we need to be familiar with in regards to the radical symbol. This little 3 right here is what is called the index of a root, and that tells us what type of root we're taking. The cube root, the 4th root, the 5th root, it can be any number. And then the number underneath the radical is going to be called the radicand. Now, we're going to focus on square roots, so we're not going to have an index there because if there's no index written there, it's going to be a square root, which you're used to seeing. So first, let's just look at evaluating the following radicals. These are quick and easy because they are perfect squares. So we know the square root of 49 is 7, square root of 81 is 9, and the square root of 16 is 4. Straightforward, easy to evaluate. Now, what if I give you a radical that's not a perfect square? How are we going to evaluate it? Well, we're going to work on getting it into simplest radical form, and we're actually going to use our perfect squares to help us do that. So let me go through the steps before we look at some examples. To simplify radicals that are not perfect squares, we're going to find the biggest perfect square that can divide into the radicand, which remember is the number underneath the radical symbol. We're going to write the radical as the product of those two numbers. So let's say it's the 25 and 3, 25 being the biggest perfect square. We'll take the square root of the perfect square, which will come out of the radical, and then the non-perfect square will stay underneath the radical, and it will be simplified.
So why have I been saying to find the biggest perfect square? Let me show you. If you look at root 32 on the left side, we broke it down into root 16 times root 2, 16 being the biggest perfect square that can divide into 32, and it would simplify down to 4 root 2. Now look at the right-hand side. I used root 8 and root 4. 4 is a perfect square. It's not the biggest perfect square, but it still works. Look what happens. So root 8, root 4 would break down to 2 root 8, but root 8 can keep going. I can divide root 4 into it and get root 4 times root 2. Root 4 would come out as 2. Root 2 would stay where it is. And then when I multiply it by the 2 from above, I get down to 4 root 2. You get the same answer, it just takes a couple extra steps. Okay, so just a strategy to help you with simplifying radicals. If you look at the first bullet point, to find the biggest perfect square that can go into the radicand, I always suggest to start with the highest number on the perfect square list and work your way down. That way you're going to hit the biggest perfect square first and be able to simplify it all in one step. And I'll go through that a little bit more in detail when we are practicing in class so you can see what I mean by that. And then if you look at the last bullet point, just remember that the perfect square comes out of the radical and the non-perfect square will stay underneath the radical. So that wraps up the lesson on simplifying radicals that are not perfect squares. Hopefully you took down the notes, the steps, and you wrote down some examples so you have that to look off of as we are practicing in class.